Structs. Structs are structured data type. Just like arrays, they are structured data types compared to our integral data types that we learned earlier, such as int, char, double, etc. Structs at times are also known as records. They can be, like arrays, homogeneous. All right, with arrays, you're either an int or a double or a string. All the values have to be of that particular data type. All right. With structs, they can be heterogeneous, meaning that you can have an int, you can have a double, you can have a char, you can have a string, etc. within that one data structure, that one structured data type. Here's a syntax here for a structs definition. All right, you would say struct, struct name, data type, and then the identifier such as int, could be salary, okay, or it could be a data type, string, first name, string, last name. All right, these here are what are known as members of the strut. Members of the strut. Note that the semicolon here is required when defining your strut. If you wanted to also declare a struct variable, you could simply just add your variable name here. Okay, or later on you can say what your strut name is and then say your variable. It's up to you. In terms of aggregate operations, believe it or not, you can assign one strut to another. All right, with arrays, you weren't able to do that. Okay, so with struts, you can do that. However, some things must be done one member, these are our members here, at a time. In regards to relational operators, for instance, if, let's just say, Gryffindor dot name, for like a name of a student in Gryffindor's house, is actually equal to new wizard dot name. Okay, then something. Okay, if you were to say if Gryffindor, which is the variable name for the strut, equals to new wizard, which is another variable name for another strut, this would not be okay. What also must be done one member at a time is when you're inputting and outputting, just like with arrays, they need to be done one member at a time, and usually you'll do it through a loop. With arrays and struts, you can have arrays in struts. Okay, and you can also have struts in arrays. You can also have a struct in a struct. A good example of that actually happening is when you actually have a real large strut. You can actually break it down into subcategories. For instance, since some members in a large strut may be accessed more frequently and some members may be closely related, or some members will have the same underlying structure such as int or char, it gives way to create subcategories. And those subcategories, those struts, can be members, okay, and then the identifier for the strut in a larger strut. Functions in regarding structs. Structs can be passed by value or reference. With arrays, they were just reference. So with struts, they can be value or reference, and they can return a value of type strut. Let's look at an example. Here's the strut array function example. This is the strut array function example doing the exact same thing we did earlier in the array example. So if you don't recall what happened in the array example, take a look at the array presentation and the example we used there. So here's my header files, namespace. I have an enum here to help me read my code. All right, of house type identified by variable name row. Here's my strut. They're up here globally because I have my function down here. That's how I wrote it. Category type. All right, so it's going to be a string house, int honesty, integrity, attendance, academics, and Quidditch. So what's going to happen here is that oh, here it is. House cup, which is of category type, all right, is going to house like Gryffindor, and then all the points in each of these categories to determine who wins the house cup at the end of the year, based upon these variables here. All right, and because there's more than one house, category type, all right, house cup based upon category type is an array, which I made a constant up here. Number of houses is 4. So this is an example of a strut in an array. Here's my function prototype for the function that I wrote. Int main house cup Gryffindor dot house dot honesty dot integrity dot academics dot Quidditch. Here I'm showing that you can assign one member at a time and how to go about doing that based upon the heterogeneous data types that make up the strut category type data type, aggregate data type. Later on I say row equals Ravenclaw. Remember, row is the name of my enum. It goes from Gryffindor all the way to Hufflepuff. So since I already did Gryffindor, I'm going to be on Ravenclaw. House cup Ravenclaw.house, Ravenclaw. Here I'm going to enter in the points for these categories for Ravenclaw, or solicit the end user to do it. All right, cout and then cn. and then it's for Slytherin. Works just like the array example. And here it is for Slytherin, here it is for Hufflepuff. And then here I'm calling my function, print cup winner, house cup. So here's my void, print cup winner, category type of house cup tab array for Gryffindor. Now I'm going to start back at Gryffindor, work my way to Hufflepuff, equals row less than equal to Hufflepuff. Got to say equals this time because Hufflepuff is at the end. Row equals static cast row plus 1. So this is my plus plus, and this is just the syntax for it to happen because I'm working with enumeration. Cout, house cup, row, house, scored a total of, and then each time it cycles through for Gryffindor, and then for Ravenclaw, Slytherin, and then Hufflepuff, it will add it up, honesty, integrity, academics, and Quidditch for me. So let's go ahead and run this. And the points for Ravenclaw, because remember, for Gryffindor, we already assigned each member. So Ravenclaw we'll just say is 5, 5, 5, and 5. Slytherin, we'll give them 0s. Hufflepuff, we'll give them 7s. And there you go. Total score from Gryffindor, Ravenclaw, Slytherin, and Hufflepuff. So instead of using just arrays this time, where we had to use, if you recall, a multi-dimensional array with a parallel array just to get our printout right, here we just used a structured data type that allowed us to, well, depending upon the user or the code writer, allowed us to write simpler code. And that's it for Structs.